Here's problem 37-8. Two slits are illuminated with red light, wavelength 650 nanometers. The slits are 0.2 millimeters apart, and the distance to the screen is 1.25 meters. What fraction of the maximum intensity is the intensity measured at distance 3 millimeters from the central maximum? Let's write down what we got. Wavelength is 650, if I can make this thing right, nanometers. We have the slits are 0.25 millimeters apart. Distance to the screen is 1.25 meters, and y is equal to 3 millimeters. So in terms of just meters, this is 6.5 times 10 to the minus 7 meters. We have 2.5 times 10 to the minus 4 meters. We have 1.25 meters. And we have 3 times 10 to the minus 3 meters for all of our values. Now in general, the intensity on the screen is going to equal the maximum intensity times the cosine squared of pi dy over lambda L. So in this case, that is going to be equal to the maximum intensity times the cosine squared of pi times d, which is 2.5 times 10 to the minus 4, times y, which is 3 millimeters, 3 times 10 to the minus 3, over lambda, which is 6.5 times 10 to the minus 7, times L, which is 1.25 meters. Let's calculate all that. And everything inside I've got is 2.8999, so 2.9. So we have that this is equal to I max cosine squared of 2.90. Now when we evaluate this cosine, make sure that we evaluate it in terms of radians, because that's what we have in there. So if I take the cosine squared in terms of radians, we get 0.9427. So our intensity is equal to our maximum intensity times 0.943. So it's 94.3% of the maximum intensity, or 0.943 of the intensity of the central maximum.